In this video, we're going to find the mean, variance, and standard deviation of a discrete distribution. I'm going to show you how to use these formulas up here first. I'm going to use this formula here and this one over here. This one for variance and this one for mean. We've already used the mean formula when we found the expected value. It's really the same thing as the expected value formula. So let's go ahead and get started here. And I've already put these values into the calculator to get me started. So stat, edit. Actually, let me clear some things out here. Talk about what I did over there in just a second. But here's my L1 is my x's, which is the dogs, and my L2 is my p of x's. Let's just show you first what the answers are supposed to be. The calculator will do this for me. But if I stat, calc, one variable statistics, and then L1 is my x's and L2, my frequency list, I'm going to use as my p of x's, and I calculate this. Then my mu here is going to be x bar is 0.547, and then the variance is not given to me, but the standard deviation is here of 0.9261700.708. I'm going to have to square that in my calculator to get my variance. So let's go ahead and do that. 0. Let's see what it says that VARS statistics. Let's see what it says this is. If it remembers it. Good. That's it. And we want to square that. And we're going to get 0.857791. When we round these, this is going to be 0.5 when we round to one decimal place. This is going to be 0.9 when we round to one decimal place. And this is also going to be 0.9 when we round to one decimal place. Now let's go ahead and show you how to do this by hand. Have our x's of 0, 1, 2, 3, 4, 5. Going to go ahead right now and calculate my x squareds. 0, 1, 4, 9, 16, and 25. I want my x times my p of x. And I'm also going to need my x squared times my p of x. I'm going to let my calculator do that for me. So that's what you saw in L3 and L4 over here a little bit ago. So L1 times L2 gives me all these numbers here. 0, 0.213, 0.178, 0.066, 0.06, and 0.03. And here I'm going to take my x squared. Oh, hang on. I multiplied by the wrong thing here. Let's clear that, go up here. This is x times p. Yeah, that's right. And then this one is x times p of x we got. And this one is x squared times p of x. All right. And this is 0, 0.213, 0.356, 0.198, 0.24, and 0.15. I actually need the sums of these lists here. So I'm going to second list math number 5, and that's going to be L3 is times L2. Let's try that again. And that's 0.547, just like we said here. And L4, this is going to be 1.157. So to get my variance, I need to take this 1.157 and subtract 0.547 squared. And that's where we get this number here. And then I take the square root of that number to get this number here. Okay, so interpret the results in the context of a real life situation. That here. Household on average has 0.5 dogs with a standard deviation of 0.9 dogs. All right, let's move on to the next problem here, and I'm just going to let the calculator do all this moving forward. I'm not going to use the formula. I'm going to go ahead and go into my memory here and clear all my lists. There we go. And 0, 1, 2, 3, 4, 5, 0.270, 0.301, 0.240, 0.134, 0.042, 0.013, and stat calc. And we have our mean of 1.4. Our standard deviation is 1.2. And vars 5, 4 squared, 1.5. The mean is 1.4. So the average batch of 1,000 machine parts has 1 or 2 defects because it's between 1 and 2. The standard deviation is 1.2. So the typical number of defects in a batch of 1,000 deviates by about 1 defect here, like that. And that's it. Just showing some rounding here that 1.4 is about halfway between 1 and 2, and 1.2 is about 1 there. So there we go. That's it for this video, and we'll come back next time and talk more about 4.1. See you for the next video.